Hi everyone. In the last class, we discussed about the finding the Laplace transform and inverse Laplace transform by applying the various theorems or various properties. Now, as up to now, we have discussed about the information of finding the Laplace transformation and inverse Laplace transformation. Next, the use of the so many applications are there. The applications of the Laplace transforms, many applications are there. But in our syllabus we were going to discuss two applications. They are solving the ordinary differential equation by using the Laplace transform concept or inverse Laplace transform and Laplace transform concept. We can find the solution of the ordinary differential equation. Next, one more application we have, it is finding the solution of the integral equation. That is the next application. Now, application to the ordinary differential equation. Suppose if I am going to consider the nth order linear differential equation, that is d to the power of ny by generally dx to the power of n I am taking, but instead of x I am taking the independent variable as d to the power of n plus a1 into d to the power of n minus y by dt to the power of n minus 1 plus a2 into d to the power of n minus 2y by dt to the power of n minus 2 plus so on. Here an minus 1 plus so on an or an minus 1 into dy by dx or dy by dt plus an into y is equals to some function of t. This is the nth order linear differential equation with the dependent variable y, independent variable t, with the initial conditions also given. It is y of 0 is equals to some k1. Yes, that is why. What is the meaning of y of 0? At t is equals to 0, at t is equal to 0, y value is y k1. Here it is y of y dash of 0 is equals to some k2. Yes, y double dash of 0 is equals to some k3. So on, y to the power of n minus 1 of 0 is equals to some kn minus 1. Kn minus 1. These are the initial conditions. That's why we say that it is the initial value problem. The conditions, the boundary conditions, the condition defined at a one point, we say that is initial value problem. If I am taking the a second order differential equation, that is some y double dash plus k into y dash k1 into y dash plus some k2 into y is equals to 0, with the initial conditions y of a is equals to, or y of alpha is equals to some some k1, some a1, and y of y dash of alpha is equals to some a2. We say that this is a second order initial value problem. So the conditions defined at a single value, we say that such problem is called initial value problem. Suppose if we take this problem, same second order problem, it is defined at the two conditions. Suppose some y of alpha is equals to some b1 and y dash of beta is equals to some b2. It is defined two different values, alpha and beta. We say that they are the endpoints. I think these are the endpoints. It is defined at a one endpoint. We say that initial value problem. It is defined at two endpoints. So we say that it is a boundary value problem. If you take the conditions are different. If you consider these two conditions for this one, we say that the problem is the ordinary differential equation. The problem is called initial value problem. If you instead of these two conditions, if I am taking as these conditions, y of alpha is equals to b1, y dash of beta is equals to b2, we say that such problem is called boundary value problem. Don't get confused here. Yes, the difference between the initial value problem and boundary value problem is, yes, the conditions defined at a single point, we say that is initial value problem. The conditions defined at a 2 points, 3 points, so on. So we say that not only single point, such that the type of problems are called boundary value problem. Listen, for this nth order linear differential equation, so it is defined at a single value, right? That's why we consider to be it is nth order initial value problem, right? This is initial value problem. To find the solution of this problem, right? Now you know that how we are going to this is clear that it is a non-homogeneous equation. In general procedure for finding the solution of the nth order linear differential equation with constant coefficients, they are the constants. See here a1, a2, a3, an minus 1 variable coefficients. Also we have the procedure. By applying the Laplace transformation, we can find the not only initial value problem, system of equations and variable coefficients, and we can find the solutions of the partial differential equations also. Many applications are there by applying using the Laplace transformation, right? In case of differential equation or partial differential equation, system of equations, system of partial differential equation, right? In that we will discuss only two applications. They are So finding the solution of the linear differential equation with constant coefficients, that is initial value problems in case of initial value problems. Next, finding the solution of the integral equation, right? Right. The general phenomena for finding the solution of the nth order linear differential equation, you know that first we can write the auxiliary equation, that is f of m is equals to 0. By solving this equation, you will get the m roots. Sorry, it is order n is there, we will get the n roots. Yes, based on the roots, if the roots are real and unequal, we can write the complementary function yc is equals to c1 e to the power of m1x plus c2 e to the power of m2x. You know that in the last semester we have discussed this, right? Finding the solution of the linear differential equation with constant coefficients. This is the procedure for finding the complementary function. Next, particular integral yp is given by, yes, we have the several procedure 1 by f of d into q of x. If q of x, that is f of t, it is depends upon f of t. If it is exponential, yes, if it is 1 by f of d into e to the power of ax, method 1, right? We can replace d with a whenever d is not equal to 0. If d is f of d is equal to 0, we can write x e to the power of ax divided by f dash of d, right? This is the one method. If f dash of d is equals to 0, we can write x square e to the power of ax divided by f double dash of d whenever f double dash of a is not equals to 0, right? Only in case of e to the power of ax. Suppose if sin ax is there, cos ax is there, sin at or cos at. So in this case, we have the direct principles for finding the particular integral. Next, not only this, sin ax, cos ax. Next, if I am taking x to the power of k, a polynomial of degree k, right? We can use the binomial expansion. We can write f of d in the form of 1 plus r minus pi of d, and we expand by using the binomial theorem and operate x to the power of k for each and every term. We will get the particular integral. Suppose the combination with sin and x to the power of k, e to the power of a xv. Yes, xv means we can write 1 minus f dash of d divided by f of d, formula is there, right, into 1 by f of d into b, right? This is one formula. A combination with exponential and function of x, and we have used the method of variation of parameters for finding the solution. Several methods we have for finding the solution of the nth order linear differential equation with constant coefficients. We discussed in the differential equations concept, right? Now, without finding complementary function, without applying the different methods for finding the particular integral, based on the concept of the Laplace transform and inverse Laplace transform, I am going to find the solution of this initial value problem, right? So that is a great advantage of it. Not only in this case, so many applications, so many advantages are there. The concept of the Laplace transform. If you go for your syllabus, your core subject, that is signal science system, completely depends upon Laplace transformation, Z transformation, and Fourier transformation, right? Okay. Now, is it clear? Okay. Now, here it is how we are going to solve. This is a procedure for solving the differential equation in case of a general method, right? Suppose we have the equation like this. Okay. Here, this is the equation. But here it is. Now I'm next after writing the given equation, taking Laplace transform on both sides, right? Here this is the LHS is equals to Laplace transform of f of t, right? You know that you can write the Laplace transform of f of t, right? You can write the Laplace transform of f of t e to the power of at, sin at, cos at, whatever we have discussed the methods, right? By using that we can write the, here it is Laplace transform of here derivatives existing here, d to the power of ny by dt to the power of n plus a1 into Laplace transform of d to the power of n minus 5 by dt to the power of n minus 1, so on you will get, no? But we have one theorem, transformation of derivatives in the Laplace transformation. Yes, just you know that Laplace transform of f dash of t, this is nothing but y dash of t, no? Suppose if I am writing this is y to the power of n of t, the nth derivative of t. Yes, you know that Laplace transform of f dash of t is equals to transformation of derivatives in the Laplace transformation s f of s minus f of 0. You know that, no? Right, s into f of s minus f of 0. In the same way, for the first order derivative, Laplace transform of y dash of t is equals to s into y of t, that is y of s is nothing but y of s if I am writing minus y of 0. Is it clear or not? Just instead of y dash of t, I am taking y dash of t by using this one for the first derivative. Next, I am trying to extend the second derivative, third derivative, so on, right? Here s into y of s, it is nothing but f of s is the Laplace transform of f of t. Y of s is Laplace transform of y of t minus y of 0, right? In case of first case. Next, if you take the second order derivative, Yes, I given the note also there. See, L double dash L of y double dash of t. L of y double dash of t is equals to s square y bar of s, that is y of s, minus s of y of 0 minus y dash of 0. This can be written as s square into L of y of t minus s into y of 0 minus y dash of 0. It is given in the problem y of 0, y dash of 0, y double dash of 0, so on, y to the power of n minus 1 of 0. Let's replace it, right? Okay, like that, if from this you can write it the y triple dash of t also. Y triple dash of t is equals to, if the third order equation is given, s cube y of s minus s square y of 0 minus s y dash of 0 minus y double dash of 0. This is the way of writing the Laplace transform, the Laplace transform of higher order derivative terms. Laplace transform of y dash of t, Laplace transform of y double dash of t, Laplace transform of y triple dash of t. In the same way, you can write the Laplace transform of fourth derivative of t is equals to s to the power of 4 y of s minus, you can expect the next term one by one. If you see the previous y of 0 minus s square y dash of 0 minus s cube y double dash of 0 minus y triple dash of 0. These are the constant, replace it, right? Then we'll get, after simplification, you will get Laplace transform of some function of t is equals to, you will get the function of s. This is the procedure, working rule to find the solution of the given initial value problem by using the Laplace transformation, right? Here it is, after some simplification, after some steps, you will get y Laplace transform of y of t is equals to, right side is a function of s. You take out, that is y of s, yes, Laplace transform of L to the right side, you will get y of t is equals to is L inverse of the function of s, right? You know that inverse Laplace transformation concept, that is which gives the solution of the given initial value problem, right? This is the method. First we write the given differential equation and taking the Laplace transform on both sides, and we replace Laplace transform of y double dash of t, y triple dash of t, y dash of t by using these results. Then using the initial conditions, we can get the Laplace transform of y of t is equals to a function of s, or y of t is equals to L inverse of function of s. This is a function of t, which is a function of t, right? If you go for the problem, we'll get a clarity, but you know that some notations I am trying to write here is dy is equals to dy by dt. This is same as y dash of t. This is same as y to the power of 1 of t. Next, d square y is equals to d square y by dt square. Here it is y double dash of t. Here it is, sometimes instead of t x is given, don't get confused here. It's y second derivative of t. Next, in the same way, d cube y is equals to d cube y by dt cube is y triple dash of t. This is same as third derivative of t, right? Apart from this is the first note. Here second note, just we are going to write Laplace transform of y dash of t is equals to Laplace transform of y dash of t is equals to L into Laplace transform of, generally y of s. Y of s I am writing it is Laplace transform of y of t, right, minus y of 0. Next, Laplace transform of y double dash of t is equals to s square Laplace transform of y of t minus s y of 0 minus y dash of 0, right? Laplace transform of y triple dash of t is equals to s cube. It is from the theorem, we have the transformation of derivatives theorem, from that I am writing here y dash of y of t minus s square y of 0 minus s y dash of 0 minus y double dash of 0. Like that you can write the higher order derivatives, right? This is the way. We are taking the Laplace transform on both sides and replace these terms with the right side terms and substitute the y of 0, y dash of 0, y double dash of 0, right? Then simplifying it, we'll get the Laplace transform of y of t is equals to function of s. Yes, you take out that Laplace transforms to the right side, or taking inverse Laplace transform on both sides, we'll get the answer. Right, next we take the one problem on this. Listen, solve the differential equation. solve d square plus 4 into y is equals to t with y of 0 is equals to y dash of 0 is equals to 0 is d by dt, where d stands for d by dt. Okay, suppose first I am trying to solve this problem as usual method by differential equation method. First f of d into y is equals to some q of t. The auxiliary equation is f of m is equals to 0, that implies m square plus 4 is equals to 0. M is equals to plus r minus 4. So sorry, plus r minus 2i, plus r minus 2i. The complementary function yc of t is equals to c1 cos 2t plus c2 sin 2t. Right. Next, that is yp of t is equals to 1 by d square plus 4 into, that is q of t is equals to t is there. We can write it is 4 if you common, 1 plus d square by 4, it is t, 1 by 4, 1 plus d square by 4 all to the power of minus 1 of t, expanded by using the binomial expansion, t into 1 t, right. Sorry, first expand it, 1 minus, it is a d square by 4 plus d to the power of 4 divided by 4, it is 60, that is for 16, so on, alternative positive negative into t. So multiplying with t, 1 by 4, here it is t, second derivative of t is what? First derivative is 1, second derivative is 0, the every term becomes 0, only t by 4 we have. So yp of t is equals to t by 4. So solution is y of t is equals to c1 cos 2t plus c2 sin 2t plus t by 4. This is the solution, but not at all solution is not completed. The conditions given at that you are going to find that means the function is defined, y of 0 is equal to 0, y dash of 0 is equal to 0 means it is defined some at a one's initial value, right? So you are going to evaluate these are the arbitrary constants c1 and c2, need to evaluate it by using this y dash of t I am trying to find. c1 cos 2t derivative is what? Minus sin 2t into 2, that is minus 2 c1 sin 2t minus 2 sorry plus 2 c2 cos 2t plus 1 by 4, t derivative is 1, right. Now I am going to write y of 0 is equals to 0, that implies c1 into cos 0 is 1, c1 plus c2 into sin 0 is 0, there is 0, c1 is equals to 0 we have, c1 is equals to 0, is it clear? c1 cos 0 plus c2 sin 0, 0 by 4. Next, y dash of 0 also 0, which is equals to, that implies minus 2 c1 into sin 2t sin 0 is 0, 2 c2 plus 1 by 4. So which is 2 c2 is equals to minus 1 by 4, c2 is equals to minus 1 by 8. So the solution becomes, according to this one, what is the solution there? Y of t is equals to c1 is equal to 0, c2 is equal to minus 1 by 8, minus 1 by 8 sin 2t is plus minus 1 by 8 sin 2t plus t by 4. This is the final solution of the given initial value problem by using this method. Sir, already we have the method, why we use the Laplace transformation, right? If you go for the practical problems, this is the analytical solution, right? If you go for the practical problems, here if you use some softwares, right, we have the MATLAB software also. By using MATLAB or other softwares, or if you go for in the mobile also, if you search Laplace transformation calculator, you will get the Laplace transformation easy. That is time consuming, right? In that case, better to apply the Laplace transformation method compared to this method, right? In this method, see what are the steps you need to follow. It is a simple problem, but we know the method, so we get the solution here. Writing the given equation in the form of writing the auxiliary equation, finding the roots, based on roots, finding the complementary function, then you take the particular integral method you are going to choose, which function is there in the right side. So t is there, that is a polynomial of degree 1, that's why you will get it easily, right? If t to the power of 4 is there is a problem, right? If Laplace transform of t to the power of 4, I can write it, that is 4 factorial divided by t to the power of 5 directly, right? So there is a complexity here, right? From that you will get a particular integral, then taking the initial conditions, you will get the arbitrary constants and substitute the arbitrary constants, you will get a solution. This is the way, right? But same problem I am going to find by using the Laplace transformation, right? Listen. Just remember the solution, just you can verify the solution also. Y of t is equals to C1 0, C2 is minus 1 by 8 sin 2t plus t by 4. We expect this solution. Okay. Now, given initial value problem or in given differential equation, given initial value problem, I am writing in the standard form y double dash of t plus 4 into y of t is equals to t, right? With the conditions y of 0 is equals to y dash of 0 is equals to 0. Say this is 1. Taking Laplace transform on both sides. Taking Laplace transform on both sides. So Laplace transform of y double dash of t plus 4 into y of t is equals to Laplace transform of t. Right, Laplace transform of y double dash of t by using the linear property plus 4 into Laplace transform of y of t is equals to Laplace transform of t to the power of n is n being a positive integer, n factorial divided by s to the power of n minus 1. It is 1 factorial divided by s to the power of n plus 1, that is 1 plus 1, right? But you know that Laplace transform of y double dash of t is equals to what? S square Laplace transform of y of t, just now I written, minus s y of 0 minus y dash of 0 plus 4 into Laplace transform of y of t is equals to 1 by s square. Right, y of 0 is equal to 0, y dash of 0 is equal to 0. You can common Laplace transform of y of t in these two cases, right? If you common, so s square plus 4 Laplace transform of y of t is equals to, if the terms are there, you take out the right side. Here it is, the terms become 0. Y of 0 is equals to 0, y dash of 0 is equals to 0. That means except these terms, no terms are existing in the left hand side. So which is equals to 1 by s square. You take out s square plus 4 to the right side. So Laplace transform of y of t is equals to 1 by s square into s square plus 4. Right. But we need to find y dash of t, y of t, no? That is the solution, right? Y of t. So how we can get the y of t here? Y of t is equals to, you take out this L to the right side, L inverse of 1 by s square into s square plus 4. Right, if you find out this L inverse of 1 by s square plus s square into s square plus 4, the problem is over. That is the solution, right? Without writing the auxiliary equation, without finding the roots, without writing the complementary function, without writing the particular integral, and after getting the solution, after getting the particular integral, we write the complete solution is given by complementary function plus particular integral, and by taking the initial conditions y of 0 is equal to 0, you will get the equation in terms of c1 and c2. And y dash of 0 is equal to 0, you will get another equation of c in terms of c1 and c2. By solving these two equations, you will get the arbitrary constants value c1 and c2. After getting the arbitrary constants c1 and c2 and replace c1 and c2 in the given solution y of t, that is a complete solution. That is a general procedure, right? But here it is, if you get this one, it will be the solution, right? How we are going to find that one? But that is depending on you, right? How you are writing the inverse Laplace transform in the easy way by using the previous methods, that is depending on you, right? Sometimes, not here, sometimes if you go for this some particular problem, some research problem, right? In that case, I don't want to go for the method of finding the inverse Laplace transformation. Just I am going to use some the related inverse Laplace transform related software, right? Directly I will get the answer, right? Without knowing that all these cases, right? That means that depends upon that means our time. Right, that means that depends upon the problem also, right? In this case, compulsory you need to evaluate it inverse Laplace transformation by expanding the partial fractions, right? Okay, so how we are going to write L inverse of 1 by s square into s square plus 4? This can be written as, but by using inspective, this can be written as 1 by 4 L inverse of, listen, here it is 1 by s square minus 1 by s square plus 4. Is it clear? If you take s square into s square plus 4 is LCM, s square plus 4 minus s square get cancel. Here 4 numerator 4 is there, that 4 get cancelled, we get the same thing. Okay, which is equals to 1 by 4 L inverse of 1 by s square minus L inverse of 1 by s square plus 4, right, which is equals to 1 by 4 s, and being a positive integer, what I am writing, L inverse of 1 by s square, that can be written as L inverse of 1 by s to the power of n plus 1, which is equals to t to the power of n divided by n factorial. Yes, s to the power of 2 can be written as 1 plus 1. So t to the power of 1 divided by 1 factorial minus, here it is L inverse of 1, this can be written as s square plus 4 can be written as s square plus 2 square. L inverse of 1 by s square plus a square, it is 1 by a into sin at. Here it is 1 by 2 into sin 2t. See, multiplying with 1, t by 4 minus 1 by 8 into sin 2t, which is the solution. No? See, t by 4 minus 1 by 8, this solution is same, no? Minus 1 by 8 plus sin 2t, minus 1 by 8 sin 2t plus t by 4 is same as t by 4 minus 1 by 8 sin 2t. This is the way, right? Is it clear? This is the way of finding the solution of the given differential equation by using the Laplace transformation method. This is a application. Next problem. Yes, this is the procedure. I will give the problems. You are trying to solve the problems. Next. Second problem, the same way. D square plus 1 into y is equals to 6 cos 2t if y is equals to 3, dy is equals to 1 when t is equals to 0. Don't get confused. That is y of 0 is equals to 3, y dash of 0 is equals to 1. So dy is nothing but y dash of t. Y it is nothing but not only y is a dependent variable. It is same as y dash of t. Dy stands for it is y dash of t. Right? If I am writing y, it is depends upon x. Sorry, t here. Okay. Now coming to solution. Given differential equation, given that, better to write in terms of t. Y double dash of t plus y of t is equals to 6 cos 2t. With the initial conditions, y of 0 is equals to 3, y dash of 0 is equals to 1. So taking Laplace transform on both sides. So Laplace transform of y double dash of t plus y of t is equals to Laplace transform of 6 cos 2t. So this is same as Laplace transform of y double dash of t plus Laplace transform of y of t is equals to 6 into Laplace transform of cos 2t. That implies Laplace transform of y double dash of t. Laplace transform of y double dash of t is what? S square into Laplace transform of y of t minus s into y of 0 minus y dash of 0 plus Laplace transform of y of t. 6 into Laplace transform of cos 2t is what? Laplace transform of cos at, s divided by s square plus a square. 2 divided by s square plus 2 square. Right. I am going to common Laplace transform of y of t. So we have s square plus 1 into Laplace transform of y of t minus s into y of 0, what is given? 3. Y dash of 0 is what? 1 is equals to 12 divided by s square plus 4. Sorry, not 2 here, s. S divided by s square plus 2 square, it is 6s. Okay, after getting this step, whatever the terms without Laplace transform of y of t, you take out the terms to the right side. In the previous, we don't have any term, right? Why? In the previous initial conditions are y of 0 is equal to 0, y dash of 0 is equal to 0. Here not like that. S square plus 1 Laplace transform of y of t is equals to 6s by s square plus 4 plus 3s plus 1. Right, you take out this term to the right side. Laplace transform of y of t is equals to 6s divided by s square plus 4 into s square plus 1. Here it is plus 3s divided by s square plus 1 plus 1 divided by s square plus 1. Now from this you will get the y of t. L inverse of, by using linear property separating, I am writing separately, s square plus 4 s square plus 1 plus 3 into L inverse of s divided by s square plus 1 square plus L inverse of 1 divided by s square plus 1. In this method, only one step you are going to do, finding the inverse Laplace transformation is the problem, right? Remaining is just you are using the formula for L y double dash of t or L y triple dash of t and replacing y of 0, y dash of 0, then writing this in this form. Here if you are finding this in the right way, that will give that is our solution, right? So this can be written as, how we are going to write this one, by using the partial fractions, or not only partial fractions, I am writing by common sense, I am writing here it is 2s into or L inverse of, it is 2s into 1 by s square plus 1 minus 1 by s square plus 4. Is it clear? S square plus 1 into s square plus 4 is LCM. S square plus 4 minus s square minus 1. 4 minus 1 is 3. 4 minus 1 is 3. 3 into 2 is 6s. Right, no problem. Plus 3 into, this is a direct formula, it is cos t. This is also direct formula, it is sin t. Right. Now see, here just you take out this 2. Here it is again we use the linear property, L inverse of, or 2 into L inverse of, 2 into L inverse of s divided by s square plus 1 minus 2 into L inverse of 1 divided by s square plus 4 plus 3 cos t plus sin t, yeah, which is 2 into, which is nothing but cos t, minus 2 into, here it is 2 square, no, 4 can be written as 2 square. Let's see, 1 divided by s square plus a square is what? Sin at by a, 1 by a into, or 1 by 2 into, or if you write 2 in the numerator directly you will get, right? As multiplying with 2, no need to write this one. Direct, if you are writing 2, you will get the sin 2t directly. It is sin 2t plus 3 cos t plus sin t. So final solution, tell me, 2 cos t plus 3 cos t, it is 5 cos t. 5 cos t yeah, it is 5 cos t minus plus sin t minus sin 2t. This is your solution, right? Yeah, this is the problem. Next, in this way you are trying to solve some problems. I will give some problems, right? In a simplification, if there is any mistake, then correct it, right? Finding the inverse Laplace transformation is very important. Next, third one, d square plus 4d plus 8 into y is equals to 0 y of 0 y dash of 0 is equals to 2. D square plus 2 whole square into x is equals to 4 e to the power of minus 2t. X of 0 is equals to minus 1, x dash of 0 is equals to 4. Here don't get confused here. Independent variable is t, dependent variable is x. That means here we have the L of y of t, no? Here what we are going to write? L of x of t. We will get x of t. Why? The dependent variable is x and independent variable is t. Same problem is same, but here it is instead of y, what is there? X. Fifth one. Y double dash minus 3y dash plus 2y is equals to e to the power of 3t. Y of 0 is equals to y dash of 0 is equals to 0. Here for this problem, d square plus 4 whole square is there. So expanded d square whole square d to the power of 4 plus 4d square plus 4, right, d to the power of 4, y x to the power of 4 of t, right, replace it. As after getting the solution, you can check whether your solution is correct or not. Just you put that solution in the given equation. That means from this y of t you have find out y double dash of t, y dash of t, and that is y of t already there. Substitute if it is satisfying the given differential equation, it is the correct solution, right? That is a way of checking whether your solution is correct or not. Sixth one, d square plus 9 into y is equals to cos 2t, right? You try it, this problem, y of 1, here it is a boundary value problem, but we can solve it. Listen, in this problem, what we have, we need y dash of 0, right? We need y dash of 0. Just you are going to take y dash of 0 as capital A. See, try this problem. As in the previous problems, y dash of 0 is given, it is not there, y of pi by 2 is there. What you are going to take, let y dash of 0 is equals to some constant, substitute it and continue the same problem, right? You will get the solution in terms of A. Are you following? Right? Y of 0 is given, y dash of 0 is not given, so that's why I am taking y dash of 0 as A and substituting that A in the when I am taking the Laplace transformation in the given problem and continue the procedure. After getting the final solution, how we are going to find A? By putting some pi by 2 is equal, this condition is given, no? Yes, if we have the y dash of y of t solution, right? Y of t is equals to some plus A, some we have. So y of pi by 2 is equals to some A into some we have. From this you will get the A value. Substitute that A value in the given solution, that is the final solution, right? Is it clear? Try it, definitely you will get the answer. Next, d to the power of 4 minus 1 into y is equals to 1. Yes, y is equals to dy is equals to d square y is equals to d cube y is equals to 0. What is the meaning here? Y of 0 is equal to 0, y dash of 0 is equal to 0, y double dash of 0 is equal to 0, y triple dash of 0 is equal to 0. Right? From this, you are trying to solve these problems. This is the first application. Next class, we go for the finding the solution of the integral equation. That is a new for you, right? Finding the solution of the integral equation, right? By using the Laplace transformation method.